Okay, I hope you're all here. Always have to double check, make sure. Yep. Oh, shoot. Now you can see the answers. Darn. I didn't want that to happen. All right. I got to have confidence. Okay, so this is on Dan Osmos. And so he died in 1998, so that's almost 18 years ago. And so some other things have taken place in a fatal, in a daredevil stunt that he was doing off Yosemite. But that rock climb you just saw, that was pretty amazing. So he went 400 feet, about 136.4 meters, and probably has a mass of 65 kilograms. Might be a little bit more because he's pretty muscly, and muscle has a lot more mass, is heavier. Well, it has more mass because it's denser than good old flabby me. And how much work did he do? So he 65 times mg times the distance that he went, 136.4 meters, about 86,000, almost 87,000 joules. Okay, so here's a puzzle. A man pushes a heavy crate across a horizontal floor. The gravitational work done by the Earth on the crate. Okay, so how much work did the gravity do? Well, gravity is pointing straight down. Now, gravity did a lot of work on Dan Osmos if he let go. Okay, so the gravity is pulling him down. But in this case, notice it's equal to 0, actually, because work is parallel to the force, or anti-parallel. In other words, if I lift something up, the work done by gravity is negative work, but the work done by me is positive work, and the net work is 0, right? In a perfect system, right? And so it's 0 because it's perpendicular, all right? Because the force is perpendicular to the displacement, so it works. So gravity here is not doing any work. What's doing work is this beleaguered guy pushing this crate this way. And then what's working against him is what's doing the negative work is the frictional forces pushing that way. In fact, friction is what gets you to walk. Weightlifting question. Okay, if the bar is 2.5 meters off the ground and the bar plus the man on top have a weight of 3,000 newtons, how much work is the weightlifter doing right now? Well, we know work is force times distance. So he's got a force. It's already 2.5 meters off the ground, though. We've already gotten it up that high. Times the distance. Well, it's not going anywhere. Force times nothing be nothing. So that's 0. Now, power, here's the thing on power. Power is you're under my spell, move this filing cabinet, whatever. Okay, so power is how quickly work is done. That's a great definition. My boss who came up with this, with these slides, and I've adapted them for this course, is a genius at just cutting through the BS and saying, power is how quickly work is done. In other words, it's the joules divided by time. Work divided by time. Remember, work is force times distance, so power is force divided by time. Force times velocity. That'll work. But distance divided by time is speed or velocity. So the force times the speed that you're going is equal to the force that's involved times FV. That gives you also the power. Power is measured in watts, just like light bulbs. All right, so let's figure out Dan Osmos' power output. In the previous 65 rock climber, what was his power? All right, so we're going to stop right here and we're going to go to my notes. So let's figure out how to do the power real quick, and then we'll stop on this one. Whoops, you're getting to see all the things. Gosh dang it. What was it? 400 feet in 4 minutes and 25 seconds. All right, so 65 kilograms, I know that. So there we go. So how to calculate power. Here's notes, page 2. How to calculate the power. I don't use that force times velocity very often. What I use most of the time is that power, which we measure in watts, is joules per second, which gives us, which we know the joules, the work to get up there, was mgh, and we know that the time was 4 minutes and 25 seconds. Is that what they said? All right. Well, we've got to do a little conversion here. We've got to put everything in seconds. So 2 is equal to 4 minutes times 60 seconds per minute, so I get those minutes to cancel, plus 25 seconds. So I've got 265 seconds. 4 times, this is 240, plus 25, so I got 25 seconds. So the amount of work done, the work, what did we say was 87,000 joules or something like that? Well, we calculated 65 times 9.8 times 136.5 meters, because we got the 400 feet is equal to 400 meters. Oh, do you want me to show you how to do that real quick? Want to see something cool? Watch this. Feet to meters. Thank you, Google. Well, this is, yeah, feet to meters. There it is. 1 foot is equal to 0.3048 meters. So if I know that the height is 400 feet, to get that to meters, I take 400 times feet times what did they say it was? I should know that. 0.3048 times let's go back, 0.3048 meters per foot. So the feet cancel, and that's how I got the 136.5 meters. Okay? So 65 times 9.8 times 136.5 is equal to 65 times 9.8 times. Yeah, I don't know why the great powers in the universe didn't make is 86,950 joules. So the power would be 86,950 joules divided by the time, which is 265 seconds. Okay. And that equals 328 watts. So it's about 3.3¼ light bulbs of energy that he's burning while he's going up there. All right, so out here, so that's some good calculations you got there.